Okay, welcome to part 2 of this video talking about carbon-14 dating. So here's the formula. Once we derive this formula, you won't have to derive the formula again, so that's nice. So our tree initially, our tree initially had 100%, or 1 as a whole number, 1. So we'll say the y for our tree, the A value, initially it had 100% of its carbon-14 atoms. E to the k is what we're solving for, times t. We'll say after 5,760 years, it has half of the carbon-14 in it. So that would be 0.5. And solving this, you divide by 1, it doesn't change anything. You ln both sides, ln of 0.5 equals, bring down the 5760k, ln e, which ln e cancels. So k equals ln of 0.5 divided by 5760. And if you do that on your calculator, you'll see your k value. So here's our k value, negative 1.2034 times 10 to the negative 4. So our equation that we can use is this. Y equals A, E to the negative 1.2034 times 10 to the negative 4 t. So this is the equation that you'll use on number 14 on your homework. And I direct you to your class notes on your homework sheet. So that's number 14. So I'll use it twice in the next 2 examples. So a paleontologist examining the bones of a woolly mammoth. A woolly mammoth is basically a really hairy elephant that lived a long time ago. Woolly mammoth. They estimate that the woolly mammoth contains only 3% as much carbon-14 as it would have contained when it was alive. How long ago did the woolly mammoth die? So we're going to use the formula we just derived right there. So y equals A, E, negative 1.2034 times 10 to the negative 4 t. And your y value, well, we'll start with our A value. We assume that the A value, based on my wonderful picture right here, the A value starts at 100%, or 1 is the A value. So that's our A value, E to the K, T. And our Y value is how much is left of carbon-14. So how much is left? Well, that's 3% left. So 3% as a decimal would be 0.03. And then you can solve for T by logging both sides, ln both sides. So you have ln 0.03 equals negative 1.2034 times 10 to the negative 4 t. And the ln and the e cancel on the right side. Solving, you would get ln 0.03 divided by negative 1.2034 times 10 to the negative 4. And you can do that on your calculator and you get this. 29,139 if we round to the nearest year. 29,139. So with carbon-14 dating, this paleontologist estimates that the woolly mammoth died 29,000 years ago. And let's look at another example that's really similar to this one. The only thing is we have a debate among paleontologists. This one thinks that it's 12%. So we would have y equals AE to the KT. Our A value, again, we assume that the tree, or in this case the woolly mammoth, has 100% when it was living. Initial is 1 for 100%. E to the K, which we found earlier, 10 to the negative 4. So x times t. And the amount after it's died and many years have gone by, the amount is this 12%, is the y value, so 0.12. And solving this is really similar to solving the last one. So see if you can solve this, pause this video, and solve. we have this work, similar to above. So the answer would be ln 0.12 divided by, use a parenthesis here, negative 1.2034 times 10 raised to the negative 4. 17,619. 17,619 years. So what I want to point out is based on your initial estimate, you can be as much as, in this case, 12,000 years off with your estimate. 12,000 years off. So what are some assumptions in carbon-14 dating? Some people think that the Earth is very old, and other people think that the Earth is very young. It seems like carbon-14 dating would say, well, it's pretty obvious that the Earth is very old if this mammoth lived 29,000 years ago. Well, there are a couple assumptions in carbon-14 dating. Probably the biggest assumption is this right here, that mainly the latter half, that carbon-14 decays continuously at a fixed rate. If it doesn't decay continuously at a fixed rate, then our estimates can be really off. So down here we could say, does carbon-14 decay continuously? And we could say, does carbon-14 decay at a fixed rate? So for instance, if it's not a fixed rate, and maybe early on it decays slow, but then it gradually speeds up, then it would increase the years old that we think the amount is. Another question we can ask is, how do they obtain their estimate? Because as I showed you earlier, one paleontologist might say 3%, another 12%, and we got 12,000 years off, which is a really big margin of error, 12,000 years. So how do they get their estimate? And there are some other assumptions, but I think that suffices to say that there are a lot of assumptions with carbon-14 dating that you might want to question to make sure that your estimates are accurate. Thank you for watching this video.